Okay, so in this video, I'm just gonna introduce the complex numbers. We know that we have like a number line starting at 0, and we have 1, 2, 3, and the numbers progress like that. Then we have -1, -2, and -3 kind of going like that, and we have numbers in between those, probably 1.5 here. I mean 0.5 here, 1.5 here, and 2.5, and also you have like numbers in between those. You get the whole idea. Now, this numbering system, we call it a real number line, and whenever you solve like a problem, see, probably you have like x squared minus 9x plus 9 equals 0. If you solve for this one, you'll end up having to have like x minus 3 square equals to 0. So when you have something like this, you end up with x equals 3. So this is a real solution because we know that 3 will be in this number line. But now we run into problems when we have like x squared minus x squared plus 1 equals 0. So now if you solve for this, you'll end up having to have x squared equals -1, which gives us problems because we don't have a real number in this number line that when you multiply it by itself, it gives you -1. We don't have that number. So what do we do now? If you solve for this one, you'll have x equals plus minus the square root of -1. And this is not a real solution because the square root of -1, you can't find it anywhere in this number line. So we'll denote the square root of -1 as an imaginary number. We'll imagine that one. We'll just imagine that one. So that leaves us with the solution to this one being negative I, or x equals positive I. So now I'm introducing like a new numbering system now. It's called like complex numbers, if you look into that. So now, how does this numbers operate actually? I mean, we can rewrite this as some like a rectangular form, a plus bi. So that will be a rectangular form of that. So let's denote that with z, because typically they denote it with z. Why? It's not really relevant. You can use any number, but typically they use z to denote that. So now here, if you look into this, you realize that a will be 0 and b will be -1 if you look into that. Now we don't necessarily need to stop at a rectangular form. We can like express this like in a polar form, where we have like r cosine the angle plus imaginary multiplied by sine the angle. Okay, well, let's focus on the polar form for a second. You know, like when you have like a circle with radius r, and let's plug in a coordinate plane on there. So you have your radius here, and then you have a point there, and you have an angle here. How you find this length here, the vertical length here? Notice that the vertical, we'll call this like an imaginary axis, and we'll have like a real axis, and a real axis here will have a in it, né? So you'll have a like that, and then for the imaginary part you'll have b there, because b goes with the imaginary part. And if you focus here, you'll have like you're gonna do trigonometry. So that means that b equals r sine theta. So that's why, like, if you say r multiplied by sine theta, you'll have b, and then you have that imaginary part there. So it's not really that complicated, really. So then for a, if you focus on a here, you notice that a is in the real number line, and then a will be r cosine that angle. So a will be equals to r cosine that angle. So that means that if z equals a plus bi, if z equals a plus b multiplied by the imaginary, and then note that a is the same as r cosine theta. So you'll have r cosine theta plus b is the same as r sine theta. So you'll have r sine theta multiplied by the imaginary. So now you can factor out the r. So you'll have r cosine theta plus, I'm just going to put the imaginary in front, because if I put it at the back, people will think that this is an angle, but technically it's like this. So I'm just going to put the imaginary part in front to avoid the confusion. So you'll have something like this. This is the polar form of that. This is the rectangular form, and this is the polar form. Notice that it denotes the same thing. It technically denotes the same thing, where r is the modulus of that. R is the modulus of that. So how do we find r, by the way? R will just technically be the distance here. Will just technically be the distance here. So you know that the distance is denoted by and the distance must always be positive, né? So I'm just gonna denote this with the absolute okay, not really necessary to put absolute there. Okay, but I'm just gonna denote that the absolute value, just gonna denote it with z here. Z here. Absolute value of z will be equals to the square root of r squared, which is equals to the square root of a squared plus b squared. Now r must always be positive, so we end up with like r being the same as the square root of a squared plus b squared, and this is the absolute value of that imaginary number. So let me just denote that with like let's say probably we have z being 1 plus 3i. So write this in polar form. If you want to write this in polar form, then you'll have you have to find r first. Or let me just represent that on a plane there. So you have an imaginary axis and a real axis, and 1 on the real number line will be found somewhere here, and 3 is positive and it's on the imaginary, so you'll find 3 somewhere there. So you'll end up with having z here as 1 plus 3i. So now when you're looking for the value of r, it's technically the distance from here to there, or you can basically just say the square root of 1 square plus 3 square. And 3 squared is 9, so 9 plus 1 is 10, so you'll have root 10. And then now you can like look for an angle. Remember, we're looking to rewrite this in like polar form, right? So now you'll end up having to have like remember, this is 1, this is 3, and this is 1, and this is root 10. So now we need to find like the angle there. So the angle theta will be the same as arctan 3, because I can't simplify that. So if you rewrite this, then you'll have like remember, we need to write it in this form: r, which is root 10, multiplied by cosine of this angle. You can use a calculator. I can't basically simplify this one, but it's just an example. Okay, so I'm just gonna keep it as arctan 3 plus imaginary sine of arctan 3. So you'll end up with something like this. You'll end up with something like this as the polar form of this. Then the absolute value of this. What about the absolute value of this one? The absolute value of z will be the same as the modulus, right? Will be the same as the modulus. Will be equals to root 10. That will be the absolute value of that. So technically you can see that it's not that complicated really, but let me just show you something very quickly. Okay, so now let's suppose that we have z equals 1 minus root 3i, and this is in the rectangular form. Now we want to rewrite this again in polar form. Now, where in the plane will we rewrite this? Imaginary part, the real axis. Now, pay attention. Let me just show you something. Imaginary and the real axis. Notice that the real part is A and the imaginary part is B, right? In this part of the plane, the first quadrant here, it's where you have A greater than 0 and B greater than 0. And in the second part of this quadrant here, it's where A it's less than 0 and B is greater than 0. And in this third quadrant here, it's where A is less than 0 and B is less than 0 as well. And in the last part of the quadrant, it's where A is greater than 0 but B is less than 0. So keep this in mind. You have like these four things here. And along this line, it's where B equals 0. Along this line, on the real number line, it's where B equals 0. And on the imaginary part, it's where A equals 0. So that's why you have to like be careful on this. Now here, you can basically see that A is positive. So we can, where is A positive? A is positive on the first and last quadrant. So we know that where that imaginary, where we'll put our point there, it will technically be in either the first or the fourth quadrant. But now notice that B is less than 0. Where is A greater than 0 and B less than 0? It's technically in the last quadrant, right? So that means we'll have our point somewhere there. Our point 1 minus root 3I. Okay, so now, so we'll just connect this point to the origin there. And now we want to like rewrite this in polar form. Our angle will be measured from the positive axis anti-clockwise, and that will be our angle. That's where you have to like be careful there. Our angle theta will be measured anti-clockwise. Of course, angles are measured anti-clockwise, and if you go in this direction, notice that you'll end up using negative angles, but we want to keep our angles positive. Now, I'm just going to construct this. This part is A and this part is B. So now, notice that we'll end up with having like the modulus. Find the modulus of that. The modulus will be the square root of A square plus B square. So the modulus will be the square root of 1 square plus negative root 3 square. Root 3 square, negative root 3 square, that's 3. 1 square, that's 1. 1 plus 3, that's 2. So you'll end up with 2. You'll end up with 2 there, with the modulus being 2. So when we rewrite that in polar form, we'll have r cosine theta plus I sine theta. Okay, so now what's cosine theta? What's the value of theta here if we look into that? We can just draw our triangle like this, and we have our theta there, and here we'll have minus root 3, and here we'll have 1. So notice that this angle is opposite to 1 and adjacent to minus root 3. So adjacent and opposite. So what ratio is that? Adjacent and opposite, it's cot. So we know that cotangent of theta will be equals to minus root 3. So if you do like a quick calculation on that, where is cotangent equals to minus root 3? That's where tan is equals to minus 1 over root 3. And that's at 30 degrees, or just pi over 6. It's negative pi over 6. So you have a negative pi over 6 there. And notice that I said you need to keep the angles positive. Ne? Okay, so you have minus pi over 6. So what do we do then if you want to keep the angle positive? Okay, so now here's something, that little trick to look at this. Minus pi over 6 is the angle here. It's this angle here, and it's measured clockwise, right? That's the reason for the negative here. But now notice that this angle here and this whole angle here will make up what? 360 degrees. If you ignore the sign of minus pi over 6. So you'll end up with having your angle theta equals 360 degrees is the same as 2 pi, and then you subtract pi over 6. So 2 pi multiplied by 6 is 12 pi. 12 pi minus pi, that's 11 pi over 6. So that's your angle there. Modulus of 2 cosine 11 pi over 6 plus imaginary sine 11 pi over 6. So that's the polar form of that. That's the polar form of that. Now, let me introduce you to something called the conjugate. The conjugate of z, we'll just denote it with z bar there. Conjugate of z will be denoted with z bar there. And if suppose that when we look at this, let me just use this example where z equals 1 minus root 3i. Z, it's 1 minus root 3 imaginary. And the conjugate, you keep the terms the same, root 3i. For the conjugate, you keep the terms the same, but you just swap with the sign here, so you'll have positive here. So you'll end up having 1 minus 3 multiplied by minus 1. How this came to be is because you have 1 by 1, that's 1. 1 by positive root 3i, that will be root 3i. Minus root 3i by 1, that will be minus root 3i. And then root 3 minus root 3 by root 3, that will be minus 3, because the square roots will technically cancel. And then you'll have I by I, which is just going to be I squared. I squared. Now notice that these two parts will cancel out, and then you have I squared. Remember, I is equals to the square root of minus 1. So that means that I squared, you'll just cancel out the square root, and then you'll have minus 1. That's why I put this here. So you'll end up with 1, negative into negative is positive, plus 3. So you'll end up with 4. So in a sense, z multiplied by z conjugate will be equals to the absolute value of z square will be equals to r square. If you look into that, the conjugate, you just swap the sign. So if you look at this one, 1 plus 5i, if you multiply this by its conjugate, then you'll have 1 minus 5i. You just technically swap the sign. Here. If it's positive, you put negative, and if it's negative, you put positive. That will be the conjugate. Thanks for watching. Don't forget to share and subscribe.